They will start with lesson 2, and this has a lot of parts on it. It is dealing with gravimetric Stoich, gas Stoich, and solution Stoich. And we'll start with gravimetric Stoich initially, but then the logic is the same thing. And then at the end of this lesson, I will make a summary of all of what we are dealing on this lesson. So gravimetric Stoich is, gravimetric means mass. So what it is calculating the mass. What we have here is mass of the known, mass in grams of known. And what we do is, in order to move from mass to moles, so we will use the molar mass. So this is moles. And how do we move from here to here is using molar mass. And then we move to moles of the unknown. Change the color. And how do we move from moles of the unknown to moles of the known is using molar ratio. And then again, we can move to mass of the unknown if they are asking for, using the molar mass. Or if the question is asking only for moles, so then we stop here. So mass of unknown using molar mass. Let's work through the example. So what we have is a copper metal react with a solution of silver nitrate to produce silver metal and copper 2 nitrate. So we'll start the very first step, as everything, because we need to know the ratios, is writing a balanced chemical reaction. Okay, so in this case, what we will have is copper is reacting with silver nitrate to produce copper 2 nitrate in aqua solution plus silver. Now the balance one will be 2 here and 2 here, because 2, yeah. Okay. Now what is given in our reaction is that we have, let's make this grams to make it a bit more complicated. So 0.250 grams of copper is reacting on this reaction. And what we are looking for, what is the mass of silver? So mass of silver. Okay. List all the unknown and known. So unknown, what we did here. And the right below the reaction, write what they're giving and what you're looking for. Okay. And the known. And do Stoich, write a Stoich statement. So now, on this case, what we have is we'll start with what is given. 0.250 grams of copper times, so we are here, grams of known. Now we will move to moles of known. Okay, in order to move to moles of known, we have to use the molar ratio. Okay, so molar ratio of copper is in your data booklet with 63.55, which is grams per mole. We have said that so many times even before in the lessons before. If we have 63.55 grams of copper, then we have 1 mole of copper. Or if we have 1 mole of copper, then we have 63.55 grams of copper. So the ratio that we will use will be 1 mole of copper as 63.55 grams of copper. So grams of copper and grams of copper is cancelled out. Now we are here at the moles of known. In order to move to moles of the unknown, which is silver, because this is what we are looking for, what we will do is we will use the molar ratio. So now 1 mole of copper is, when it is reacting on this particular reaction, produces 2 moles of silver. So the ratio is 1 moles of copper, 2 moles of silver. Or if we have 2 moles of silver, then are used 1 mole of copper. Now, the ratio that we will use in order to cancel the moles of copper will be 1 mole of copper in the denominator. It's 2 moles of silver in the numerator. So moles of copper is cancelled out. Now, when we are performing this first step of calculations, what we have is moles of copper. When we are performing the other calculations, what we have is moles of silver. And now we are looking for grams. What is the mass of silver produced? So now we will go to the molar mass of silver. And the molar mass of silver, again, in your data booklet, is 107.87 grams per mole, which means that if we have 1 mole of silver, then we have 107.87 grams, or if we have 107.87 grams of silver, then we have 1 mole of silver. Now, the ratio that we will use is 107.87 grams of silver is 1 mole of silver. So moles of silver and moles of silver is cancelled out. And what do we have after we perform these calculations is grams of silver. And this is what we were looking for. So now in your calculator, what you will enter is 0.250 times 1 times 2 times 107.87, the whole thing divided by 63.55 times 1, which doesn't really matter, you may not put it in. So what did we do here? We started with mass of known, and then we moved to the moles of known using the molar mass, and then we moved to moles of the unknown using the molar ratio, and to grams of the unknown using the molar mass again. And then enter this number in your calculator, and you should have, I think, 53 something, 9 grams of a number of grams of, well, let's do it, 0.250. So you should have here as the answer of 0.849 grams of silver formed based on these calculations here. So And what we are doing is we are taking into the consideration the significant digits. So we have 3 significant digits as we start with, and this is the final answer. And keep everything around everything at the very end. Let's move now to another example. So we have how many moles of calcium phosphate precipitate are produced when 7.5 moles of calcium nitrate are reacting in the solution with excess sodium phosphate. When you see this word here, like excess sodium phosphate, what does it mean is that you can use as much as you can until all those, in this case, 7.5 moles of calcium nitrate are used up. So let's start with a balanced reaction. So we'll have, as a balanced reaction, will be CaNO3 to aqua solution plus 2 sodium phosphate in aqua solution as well will give us potassium. This is a double replacement reaction, so it will be potassium phosphate, a solid, and 6 sodium nitrate in aqua solution. Okay, so now what is given here is a number of moles of calcium nitrate. So it is 7.5 moles, and we are looking for how many moles of potassium, calcium, how many moles of calcium phosphate are produced. Okay, so now we'll start with what is given. What is given here is 7.5 moles of calcium, potassium nitrate, NO3, and then we will move. So now, since we have moles here, so the flow chart here is telling us that when we have moles of known, in order to move to moles of the unknown, we will use the molar ratio. So let's use the molar ratio. And the molar ratio is 1 to 3 or 3 to 1. So you'll have to make a judgment which ratio are you using, 1 to 3 or 3 to 1. And the judgment will be based on the fact, how can you cancel what is the units of what is known or what is given. So this will be 1 mole of calcium phosphate is 3 moles of calcium nitrate. So moles of calcium nitrate and moles of calcium nitrate is canceled out. And then what you have is a calculation here. 7.5 times 1 over 3. And the units are moles of calcium phosphate. And the answer will be 2.5 moles. And again, considering the correct number of significant digits, we will have what it is, 2.5. Okay, now if 4.5 moles of calcium borate are produced by the reaction of potassium borate with excess calcium acetate, how many moles of potassium borate are reacting? So you have the reaction here ready, and what is given here is 4.5 moles of of calcium borate, and what we are looking for is moles of potassium borate. Okay, so again, moles of known. We start with what is given, 4.5 moles of Ca3BO32. Molar ratio here, the molar ratio is 1 to 2 or 2 to 1. It is a ratio of 1. What we are doing is we are choosing which ratio are we using, 2 to 1 or 1 to 2. So, and the one that you will choose will be the one that you are able to cancel out. And how do you cancel out? By looking at what units do you have to cancel out. So you have moles of calcium borate, meaning that the molar ratio of calcium borate has to be in the denominator in order to cancel it out. So 1 mole of calcium borate is in the denominator. It's produced when 2 moles of potassium borate are participating in the reaction. So moles of calcium borate is cancelled out. And then what do you have here as the units is moles of potassium borate. And this is what you are looking for. So it will be 4.5 times 2 over 1 in terms of the numbers. And the units will be moles of potassium borate. So the answer here will be 9.0 moles of potassium borate. Again, I wrote 9.0 because I am taking into the consideration the significant digits. And since we started with 2 significant digits as 4.5, then we have to record our answer into 2 significant digits. So let's move now to another example. Aluminum oxide decomposes to aluminum and oxygen. What mass of aluminum solid can be produced from 2.404 kilogram of aluminum oxide? Okay, so now we'll start with a balanced chemical reaction. So we dealt with this reaction even before, so I'm not staying on this reaction for a long time in order to balance it, or aluminum plus 3 oxygen. Okay, what is given here is 2.04 kilograms of aluminum, and we are looking for the amount or the mass of aluminum that is produced. Sorry, 2.04 kilograms of aluminum oxide. So we'll start with, personally, I have the tendency to write the molar mass as a given here as well, of what you are looking for and what is given. So I personally have this tendency, but you can do it as you work your way through. So the molar mass of aluminum oxide is 101.96 grams per mole. And we know that the mass of aluminum, or molar mass of aluminum, is 26.98 grams per mole. And now I start with what is given. So what is given is 2.04 kilogram of aluminum oxide. Let's convert it into grams. So in 1 kilogram of aluminum oxide, we have 1,000 grams of aluminum oxide. So kilograms and kilograms is cancelled out. So what we have here is grams of aluminum oxide. Now let's move to the moles of aluminum oxide. And in order to do that, what we will use is the molar mass. And this is why I have the molar mass here listed on the given, so that I don't have to do more calculation. 1 mole of aluminum oxide is 101.96 grams of aluminum oxide. So grams of aluminum oxide and grams of aluminum oxide is cancelled out. What do we have in terms of the units here is moles of aluminum oxide. So now we are done with the known or the given. We have to move now to the unknown or what they are asking for. In order to do so, we will use the molar ratio. So we have 1 to 4 or 4 to 2. Doesn't really matter. We have to make that judgment based on the fact that when 2 moles of aluminum oxide are reacting, 4 moles of aluminum are produced. Or if 4 moles of aluminum are produced, then we are using up 2 moles of aluminum oxide. So now again, we have 2 ratios. Ratio 1 and ratio 2, and we have moles of aluminum oxide. So in order to cancel it out, we will use a ratio 2, which is 4 moles of aluminum is 2 moles of aluminum oxide. So what we have here is moles of aluminum. Now the last step is we need grams of aluminum produced. So then what we will do is we will use the molar mass. And again, this is why I have it here, so I don't have to go back and then think, what do I have to do? So now, again, 1 mole of aluminum is 26.98 grams of aluminum, or if we have 26.98 grams of aluminum, then we have 1 mole of aluminum. So the ratio that we will use here will be ratio 2. So this being 1 and this being 2, because we need to cancel out the moles of aluminum. So 1 mole of aluminum is 26.98 grams of aluminum. And what do we have up to this is grams of aluminum. So because moles of aluminum is cancelled out, and even on the previous step, moles of aluminum oxide were cancelled out. In terms of the calculations, what do we have, our numbers, is 2.04 times 1,000 times 1 times 4 times 26.98, the whole thing divided by 1 times 101.96 times 2, and it is grams of aluminum. So when we perform this calculation, and when we write it in the form A dot BC times 10 to the power D, what we will have is 1.08 times 10 to the power of 3 grams of aluminum. If this was a numerical response, and I'm asking you to record only A, B, C, and D, so this will be something like this, A, B, C, and D. What you have to write is 1, 0, 8, and 3 as your answer. I hope that this makes sense. Let's move to the next example here. When 6.5 grams of potassium chlorate solid breaks down to potassium chloride and oxygen, what mass of potassium chloride is produced? So we'll start with the balanced reaction first. Okay, ClO3 is solid, is decomposed into 2 C and 3 2 gas. So what we have as a given here is 6.5 grams of potassium chlorate. And as I said, we are looking for potassium chloride. And as I said, like I have the tendency to write the molar mass here, and I suggest you doing that. So, but if you feel that no, you will do it while you are working with Stoich, then go ahead and do that. 74.55 grams per mole. And the way that I'm calculating is as I look at the formula and I have 1 potassium, 1 chlorine, and 3 oxygen, and I add them together. Or in this case is 1 potassium and 1 chlorine. Okay, so I will start with what is given. So 6.5 grams of potassium chloride. Yeah. So 3 times molar mass. So 1 mole of KCl3 is 122.55 grams of ClO3. Grams and grams are cancelled out. So what we have here is moles of KClO3. Now we'll move to the moles of known. So 2 moles of KClO3, it's used up to produce 2 moles of KCl. So moles of KCl2 are cancelled out. What do we have here is moles of KCl. Now we are looking for grams, so we will use the molar mass. 1 mole of KCl is 74.55 grams of KCl. And then what we have here is grams of KCl. And this is what we are looking for. So in terms of numbers, what we have is 6.5 times 1 times 2 times 74.55. The whole thing is divided by 122.55 times 2 times 1, and the units are grams of KCl. So when you perform those calculations, you should have as your final answer 4.0 grams of KCl. This is the first part of the second lesson. Since it is too much, I'm stopping here, and you can continue, or we can continue with the second part and the third part.